recording. There we go. So here we have Athena. Now, a couple years ago, me and Miss Merrill, the AP Bio teacher, we named all of these after the Greek gods for fun. And what you'll notice is that there's a knob here, a knob here, a knob here, and a little door right here. The door opens so that you can put the little tubes in, and then you close the door so that light doesn't come from out here and get into there. Then you'll see that you got a readout here. That's the wavelength. That is the reading. You can pick different types. Right now we need transmittance. And so when you go to use this, what you need to do is, first you would set the wavelength, and I have it set to 630 already. I won't mess with it. And then you have to calibrate the machine. You have to tell the machine where 0 light is getting through and where 100% light is getting through. And that's what you do with these knobs. So I'm going to mess it up to show you. So I'll mess up 0 and I'll mess up 100. This is the 0 knob. This is the 100. And so you'll see in the reading it says negative 12.8. Well, right now there's nothing in here. It's empty. And the machine blocks all the light automatically. So I need to turn this until I can get to 0. Now the machine is crazy sensitive. Sometimes it's difficult. And there's 0. If I go too far, then we get that. Yeah. And that's 0. I also need to tell it where 100 is. So you put in a sample of water, which is my number 8. I'll go in, close the door. That means it's way too high. So I turned it down, but I turned it too far. So now I'm gonna, nope, too far. And there we go. One thing I recommend is to recalibrate it, check it again. So I'll take this out. Make sure it's 0. Put this back. And make sure it's 100. And that's close enough. Now the machine is ready to go. And now we get our data. So we'll start with test tube number 1. So here's number 1. I line the line up here. There's a line on the machine that you probably can't see. In. So number 1 is 11.6. Number 2. $15.2. Number 3. $23.0. Four. 34.6. 5. 43.8. 6. 59 point, you could either say 59.6 or 59.4. 7. 7. $77.2 and 8. Of course, this was the same one we used to set 100. You'll notice it's a little off. That's okay. Just write down 100. If you do 101.2, you get some weird results and numbers. So just go ahead and do 100. Obviously, the machine got a little bit out of sorts as we went through that, but that just happens. So that's our data. I'm going to turn this one off because it's noisy. I want to show you the other version as well. And so here I have an older one. This is Aphrodite. I want to get it to where you can read the display here. So it's got the same knobs. I'll back it up again. That sets 0. That sets 100. This sets the wavelength, which I've already done. Same little door to put your samples in. But notice the gauge is different. This one you have to read yourself. So you do the same thing. You set 0, which I have. You put in the water. You set 100, which is actually a little high, so I can fix that. And then you would put your samples in just like we did before, except you have to read it this time, and we're reading the top scale, the one that goes from 0 to 100. Takes a little bit more skill on your part, but I like this one because you see the gauge move. It's more intuitive. So let's just put a couple in for the heck of it. You don't need to write these down. We'll start with number 1. So number 1 is the most concentrated. And it's reading about 11.5. That means that of the 100% light we set, 11.5% is getting through. The rest is getting blocked. If I put in a more diluted one, like number 4, notice, now it goes up to about 36. Now 36% of the light's getting through, and that should make sense because there's less blue to block the light. If I go to one even more diluted, like number 6, now we're at 60 point, it's a little tricky, like 60.2, something like that. And that's how this one works. So I actually prefer this machine when it comes to your education because of the needle moving. The other one's the better tool. Now we need to talk about what to do with this information. So go back to the green book. Back to the green book, page 19. The data we just took is the measured percent transmittance. It turns out we want to get rid of the percent, so you just divide by 100, and that gives you the measured T in decimal form. Then we're going to make some graphs. Now, step 5, we're going to skip in the page 19. It wants you to make a graph just to find the relationship between transmittance and molarity. We just did that. Just look at the data. It's pretty clear that as molarity goes down, which is the order we did it, transmittance goes up. I don't think we need to make a graph to show that. Step 6 is what we need to do. So in step 6, it says, work with your group or on your own if you want. you can work with someone else if you want to. Make a series of plots to determine if there's a linear relationship which has a positive slope and goes through 0. Now, the positive slope's important. Going through 0, that's a nice benefit, but that's okay if that doesn't happen. Between transmittance and molarity. Your teacher may assign you one type of plot to make from the list. No, your teacher's assigning you all 4, but I do have a way to speed this up for you. When you make these 4 graphs, the goal is just to find which one is a straight line with a positive slope. We're just testing them. So you don't have to do a real great job right now. So what I recommend you do is take your piece of paper, your graph paper, let's say this was your graph paper, put it into 4 quadrants. So put a line vertically down the middle, horizontally down the middle, and then just do graph 1, 2, 3, 4. Just do them small and quick, because we're just looking for the winner. One of the 4 will be the winner, the other 4 will not. Then, once you know which one is the best one, make me a full size, as in full sheet of paper, really nice version of that graph. When you do the math, so you'll see in the page 19, it has 1 over t, 1 times 10 to the t, log t, and negative log t. When you do this, you're always going to do it using the decimal form. So you turn the percent to the decimal form, and then from then on, you're just going to use the decimal form in here. And you have to do all that math. What I recommend you do is just make a big data table. So just get a sheet of paper, make a column t in decimal form, then a column 1 over t, 1 times 10 to the t, log t, and negative log t, and just get that out of the way, that busy work. And then when you make your 4 graphs, just tell me that it's on that wherever that page is. It'll probably be the prior page in your report. And then you need to make the good one, whichever one's the winner. Every time it says brackets dye, that just means concentration of dye, and that's always the same on the x-axis. That'll be the micromolarities that you already calculated in table 1. All right, look at my page, page 127. And now what you need to do is what says mid-lab. So first bullet, skip step 5 graph. I already mentioned that. Adjust this a little. Next, make a small version of the 4 suggested graphs in step 6. So this is where you're doing the 4 quadrants that I mentioned. And I talked about this already. I've got a few more hints in here. Then third bullet, make a full-size superior graph. So it will be a repeat of one of the 4. And then design a plan to conduct the investigation and answer the 2 main questions. So what this is saying is for you to think, how are we going to answer the question that's going to come up tomorrow? So let's look at that now. In the green book, flip to page 20. In page 20, about halfway down, in blue, it says investigation. Many common sports drinks contain, well, they might complain too, but they contain blue number 1 dye. Use the relationship between transmittance, absorbance, and concentration to determine the concentration of this dye in the sports drink. So the idea is tomorrow, we are going to be given a drink with unknown amount of blue. And you need to come up with a way to determine how much blue is in it. So for example, I have Powerade Mountain Berry Blast here, and you can see it's blue. So tomorrow, how are we going to figure out what the concentration of blue is in there? Obviously, you need to incorporate what we did today. So think about the graph that's the winner from today. Think about the spectral photometers that we use today, and so on, and come up with a plan for how to figure out how much of the blue is in there. Now, the stress is a little bit less on everybody right now, because normally you come up with your plan and then you do it in class. So you're under a little more pressure to come up with a good plan. Obviously, tomorrow I will use the correct plan, but I still want you to try and come up with one anyway, even though you know you don't have to actually do it. If we have time tomorrow, maybe we can talk about a few different ideas. Are there any questions right now?